going on, guys? Running the transmitter system at 15 watts, and I have it clamp locked where it can't give out more than 15 watts of power. And the transmitter is in the center. We have two relay coils, which really seem to help, and we are illuminating three 15-watt bulbs to full intensity. Well, they're 5 watts apiece, so totals to 15 watts. They're in series. And if I connect just one, it'll almost get so bright it wants to burn. So they're in series, they're giving off heat. We got real RF power here, converted to DC. Basically what I did is I combined two of my ground receiver circuits, which I described in my PDF, which is in the link in the description. And I combined those two ground circuits with two resonant receiver coils and two relay coils. So all those schematics are in the PDF. Everything is there. Nothing held back. I'll show you the interesting phenomenon when the load is disconnected. So watch the power consumption, which will be right there, the wattage. When I disconnect the load, the wattage will increase. So 14.9. Reconnecting the load. It actually slightly increased. But I can get it to where when I run loads, the wattage decreases. So this load is perfectly balanced at the moment. And it's important to note, while these 15-watt bulbs are fully illuminated with 14 watts of power, we still also have wireless power effects. And I can touch these little receiver lights to anything metal and they will light. And I still managed to keep the extreme range as well. It glows even just getting near anything that's grounded. So not only am I outputting 15 watts as light and heat through my ground extraction circuits and the receivers in parallel, I also still maintain my impressive wireless power, no degradation whatsoever. Still light fluorescence, the power gets relayed. No problem with fluorescence. All these coils are somehow relaying the power, and the range is incredible. I might sell this whole thing as a jumbo kit soon. Everything will be plug and play with a schematic how to connect it. Not sure what the price will be on that. Oh, and I should probably show the new gold-plated transmitter. Constructed with all gold-plated wire. I'm going to turn on my light so you can see it better. Turn on my work light up here. Alright, so that's on. It's a very bright work light. Here's the new gold transmitter. Very nice looking. Got a good view of it. Everything's gold plated. I was able to gold plate everything except this part of the wire. I couldn't find the stranded wire gold plated. This is silver plated, the L1. The L2 is gold plated. The L3 is just high quality stranded wire. And this sphere is a gold plated stainless steel sphere, which seems to help the most. And gold plating is pretty cheap. You can get anything like gold plated for like an extra 30-40 bucks. And they just basically what's it called, electrocoat it, where they put it in like some kind of chemical or water. Electroplate, that's the word. And yeah, so we still got that lit, 15 watts. We still got wireless power, no degradation. We can put that here. As you see, the coils are relaying it. And now I will show you, I have to get everything in tune with the capacitors. As you see, there's two capacitors here now on my L1. Also have to put a capacitor on that receiver. You have to get everything in perfect tune. And I have to put a capacitor on that receiver. As you see, I just have full bridge rectifiers. That's where all the outputs are combined. That's my transmitter. The transmitter is completely wireless. No loads are directly connected. to the transmitter. Those are 2 relay coils which lag the power and create a time varying effect for more power in a receiver coil. So yeah, now I'll connect, this might show the effect. Now I'll just connect the single bulb. So, oh, these are hot. And then the single bulb gets blindingly bright. Now as you see, the single bulb is exceptionally bright. I'll try and get this all in frame. I'm filming one-handed after I just worked a double shift at work. So, see that? We're consuming 14 watts, no load connected. Load connected, we're consuming 13. And the watt count is right there. The DC power supply runs the gold-plated transmitter. And I've got batteries coming in to run this. And I got a few of these fancy DC converter boards. 0 to 120 volt DC input, 0 to 120 volt DC output. So, pretty handy. And that bulb is phenomenal. And again, load not connected, consuming 14 watts. Load connected, power consumption drops. Keep in mind, this load is fully lit. And we still maintain wireless power effects. Absolutely phenomenal. Quick room tour. My toolbox. Nothing under the desk. That's where my ground connection goes in. Connects to the side of my dead outlet. Maintain the wireless power even over here. Phenomenal. I could put a receiver here or a ground extraction circuit between 2 ground points and boom, more power. Could combine it with the output on that light bulb and just keep going. So my workstation, the old ball, even that's accumulating energy. And it just sits on my desk. Radiant energy, guys. Absolutely phenomenal. It's just everywhere. It's like the energy collects on metal. So that's weird. Even on my LCR meter. How weird is that? I've never seen that before. That's fucking weird. Alright, so next I'll show you the output readings on my expensive meter. There can be no doubt what the readings are. Our input, 14 watts. Here's our output. We're on current right now. I'm gonna set this up. You have to bear with me. So, I know these videos aren't filmed with good quality. So here's the output wattage. I mean output amps is 2 amps. 2 amps dead short current. And that's coming from our transmitter, wireless power that's received. 2 amp output with a 285 milliamp input. And keep in mind, I still have wireless power. I can still take a fluorescent and do this while we have 2 amps there, shorted out. Like it's getting to the point where you can't degrade the system. So I'm figuring out how to duplicate the radiant energy with no effect on the source. Now I'll do the voltage. Voltage is, yeah, 40 volts DC. We'll just round it to 39 and do our measurements on the safe side. So even if these measurements are wrong, 1.92 amps. Sometimes the RF fucks up the meter, and this was a really expensive meter. So, and the output it's reading is all rectified to pure DC, and just having the meter near the coils is what messes with it. So I'm trying to keep this video under 15 minutes. I'll connect the light bulbs back up, and even if this reading is wrong, the output is still either equal to the input or greater. So the system's almost acting as a heat pump that's over 100% efficient. It's probably 300-ish% efficient. So now I will move this meter down here. I'll connect my 3 light bulbs up again, which are my favorites. They don't blind me when I connect them. There we go, they're lit again, they're all happy. And the higher the voltage I crank the system, the more efficient it becomes. Wow, that's bright. Well, the system is very voltage driven. Notice how much current driven. These guys are lit. That's bright. So I figured I'd post that quick update. Connect the single bulb. Oh, look at that. 4 strings of them now. Can just keep going. Look at that. Can just keep extending it. And I can build more receivers, get them in tune, and combine the power. Oh my god, that is bright. I'm going to bring this down to low power levels. I'm going to bring it to the point where it shouldn't even be possible to be lit. Keep it clamped at 3 watts. I'm going to clamp it. Come on, it's really hard to clamp at very low power settings. I think I got it. Clamped on low power settings, bulb is lit. And keep in mind, when the load is lit, power consumption increases. When load is lit, power consumption decreases. Let me get this in frame. Load is lit, power consumption decreases. Load not lit, increase in power. Load lit, decreases in power. Load not lit, increases in power. So keep in mind, I'm lighting up this bulb with an input of less than 2.5 watts, and I still maintain my relayed wireless power at range. That should be impossible. Not to mention, I still also have the I don't know where I put the little receiver light. Right here, maybe. Yeah, look at the range on this thing. At 2.5 watts, while an incandescent is being run, there's no doubt. Like, I'm shattering any misconceptions. All misconceptions are shattered in this video. That should be impossible to be run wirelessly, but it's not at 2.5 watts. And I still have phenomenal radiant energy. I could combine multiple receiver circuits in this area or wherever I want, combine the outputs and get that bulb to full brightness. And keep in mind, I can move this to adjust the tuning too. And if I touch the coil, I mess with the tuning as well. As you see, the bulb goes out as I touch the coil. And I gotta get a proper way to relay that without sag. I have to impedance match the antennas, maybe do a multiple flat top loaded network somehow, which would be simple. Just put it in the fancy calculators, figure out the exact wire length. should be optimal. So again, no degradation. It's getting to a point where I'm gonna have a battery run the system, and then the output, then it will I need a ground extraction circuit. It'll keep itself going and maybe output an extra 5 or 10 watts of power while it keeps itself going. So stay tuned, it's getting interesting. And as you see, I shut this off, everything goes out. There's nothing secret or weird going on. There's no hidden wires anywhere. That's actually a dead outlet. Like I said in my older videos, the only power in my room comes from an outlet that's down there. All the other outlets are dead. Then the extension cord just snakes around and runs my power strip here where I run the experiments, and that's it. So I'll turn the system back on. Back on. Should settle down to 2.3. It was clamped. Load is lit. That's an incandescent. He's lit a little above halfway. And he's lit, and I still have wireless power with no degradation at such efficiencies. So keep that in mind. It's getting interesting. And thank you again to everyone. Thank you for the support. Thank you for the motivation. Thank you to all those who bought the PDF. It's only 15 bucks. Everything I discover, constantly updated, thrown in there. With what's in the PDF now, you could easily build and replicate this system exactly as I did. You might have to experiment around a bit with different capacitor values on your setup, because your capacitance may vary based on where you ground it. Most of the time, you're going to be in the 1 nanofarad to 2 nanofarad range. It'll be around 1 nanofarad, 2.2 nanofarad range. Super important to use high quality film capacitors. And if you use any resistors at all for any purpose, they have to be carbon film. Anything else will detune the system. Have to use carbon film resistors. A lot of resistors are wire wound, which would screw it up. So, and you want to build the system as cleanly and as neatly as possible. These will eventually go. The wires that connect the relay coil, it'll be much neater. So that's just that for rough testing. I'm in love with the new transmitter design. The even bigger model will be wound on 3-inch diameter pipe very soon with an even bigger diameter ball, and that kit will be about 500 bucks. And I'm thinking of selling a super kit that can run incandescent bulbs too, and I'll include the incandescent bulbs. So it's getting interesting, and thank you again, everyone. The system's kind of acting as a energy extraction pump, similar to how a heat pump can be over 100% efficient. So thank you, and everything's getting interesting. Stay tuned.